Hi and welcome to this Leaving Cert Higher Level Maths video where we're going to cover revision worksheet 15, and this worksheet covers paper 2 section A. So question 1 is a coordinate geometry of the circle question worth 30 marks. Two circles K1 and K2 touch externally. Part A says the equation of the circle K1 is x squared plus y squared minus 6x plus 2y minus 15 equals 0. Find the centre and the radius of K1. So in our log tables on page 19, we find the circle section, and they tell us when we're given this equation in that form, the centre is minus g minus f, and the radius is the square root of g squared plus f squared minus c. So from my equation, 2g is equal to minus 6. So I'm looking here at that 2gx, and it's minus 6x, which shows me that 2g is equal to minus 6. So g is equal to minus 3. So 2f, so I can see my 2fy in my formula and the 2y up above. So 2f is equal to 2, which gives me f equals to 1. So my centre is minus g minus f, which is 3 minus 1. Then the calculation for the radius is the square root of g squared plus f squared minus c squared. Just be very careful here with your c. C is the constant and it's already negative. So here it's minus 15. What you might find is you're getting an error when you put this into your calculator. In that case, just double check the sign of that constant. Part B tells us that the centre of the two circles lie on the line 4x plus 3y minus 9 equals 0. The radius of the circle K2 is 10 units. And if the coordinates of the centre of the circle K2 are expressed in the form minus g minus f, show that 3 plus g all to be squared plus f minus 1 all to be squared is equal to 225. So the first thing I'm going to do is sketch this out. So I can see my circles here. I have a slightly bigger one and a smaller one. This is K1, which we just worked out had a radius of 5, and we've also worked out its centre. This one is K2 and has a radius of 10 units. So here are my two centres, and if I put in my centre points here, remember I've just worked out that this piece is 5, so that's from part A, and they told me in part B that that is 10, so that allows me to know that the distance between their centres is equal to 5 plus 10, which is equal to 15. So what I'm going to do is I'm going to use my distance formula from page 18, and I'm going to work with those 2 points, and I'm going to sub in. So my points that I'm working with are 3 minus 1, and minus g minus f. You can do that in whatever order you want. I've ordered these x1, y1, and I've ordered this x2, y2, but either way it will work out. So subbing that in, I allowed equal to 15. I'm going to tidy up the minuses here. So I get the square root of 3 plus g all to be squared minus 1 plus f all to be squared is equal to 15. To get rid of my square root, I'm going to square both sides, which gets rid of the square root on the left and equals 225 on the right, so 15 squared. Now my last step as well that I've done, just to point it out, is for this bracket here, it doesn't exactly match what the question had given me, so I flipped it. Now I haven't changed any signs, so it's exactly the same as what it was, but instead of saying minus 1 plus f, I now have a plus f minus 1. So that's exactly as we were asked. Part C says hence or otherwise find the possible equations of K2. So I've left in here my part B, which we'll use to help. So hence meaning using the previous part, I'm going to take the equation that I was given there. In order to find two equations, I need to find the centre and the radius. I know the radius of K2 is 10, so let me highlight this here. So I know that radius. I'm just looking for the centre. The centre is made up of f and g, so here is the first equation that I have with f and g, and I need a second one. So the second piece of information actually comes from part B and tells me that the centre of the circle lies on this line. So knowing that, I can sub it in. So the center, I'm still treating it as minus g minus f. I'm subbing it into that line because it's on the line. I know that that equation will be valid. It will be true. So that gives me minus 4g minus 3f minus 9 equals 0. So this becomes my second equation. Notice that I have a nonlinear here and a linear over there. And to follow our method from algebra of how we deal with linear and nonlinear, we take our linear and we isolate one of the terms. It doesn't matter, both of these are kind of nearly as difficult as each other because they both have coefficients. So I'm going to isolate my g. So minus 4g is equal to 3f plus 9, and I get g is equal to 3f plus 9 all over minus 4. If you have minus 3f minus 9 over 4, that's absolutely fine as well. Before I go to sub this in, I'm just going to expand my nonlinear a little bit just to make it easier. You can go straight into the substitution from how it currently looks, but because g is a fraction, and this is going to be a fraction within a bracket to be squared, it's going to get very complicated very quickly. So my advice is square out those brackets now and then substitute. So squaring out that bracket, I get 9 plus 6g plus g squared. That's my first bracket. So let me just follow this through. So there's my first bracket. My second bracket, f minus 1 squared, gives me f squared minus 2f plus 1, and that equals 225. I'm just going to rearrange that slightly and tidy up my numbers. So I have g squared plus f squared plus 2g minus 2f minus 215 equals 0. So that's all my numbers tidied up together. Now I'm going to sub in my g into the two places where it exists. So a g squared and that g. And it looks like this. So I'm going to have to work through this equation. Remember BIMDAS, and this is something that I know is quite an old idea, but you need to do these indices before you multiply out, which basically means you need to expand that bracket before you get rid of the fractions. That's a really common error. So to square a fraction, you square the top and square the bottom. So that fraction becomes 9f squared plus 54f plus 81 all over 16 plus f squared. For the 6 times that, I can put this as 6 over 1, so 6 by the numerator, so that gives me 18f plus 54 all over minus 4. And then minus 2f minus 215. I'm going to multiply by 16 to get rid of my fractions. So I'm going to multiply every piece by 16. Here, just be careful. 16 cancels, that's no problem, but 16 and minus 4. This leaves me a minus 4 that I need to multiply in. There is a minus, let me just tie this up a bit. So this is 16 by that, and also 16 here. When I do that, I get 9f squared plus 54f plus 81 plus 16f squared. Then remember, I'm multiplying the 18f plus 54 by a minus 4 because the denominator was minus 4. I was multiplying by 16. 16 divided by minus 4 is minus 4. So I get minus 72f minus 216 minus 32f minus 3440. So let's tidy that up and let's solve it. Now I have an equation that is only in f. So here's my simplified equation when I add together my like terms, and it is a quadratic in terms of f. I can see that everything ends up in 5, so we can try to see if we can simplify it down. Everything here is actually divisible by 25, and when I do that, I get f squared minus 2f minus 143. So 143 is quite a big number. If you want to use the minus b formula here, that is absolutely fine, but I'm going to use factorization. I get 13 and 11. A little trick, if you want to get factors quite quickly, and the middle number, so what they need to kind of subtract to, is very small. What that means is the two factors are going to be quite close together. So here, 13, 11. So a way that you can try find that quite quickly is try the square root of 143, or think of the square root of a number close to it. So think of 144, so 12. So you could try 143 divided by 12, and it is not divisible by 12. So then either go up or down. It doesn't matter because either way you should come to it. So then 12 doesn't work, so maybe try 13, and I get 13 and 11. So that's just a quick way if you want to work with your factors, but minus b is perfect. So my two answers here are f equals 13 and f equals minus 11. So just be aware of what the question is. I'm looking for equations of K2. So I also need my G, and I then also need to make the equations. So here's my G that I isolated earlier on. I have 3f plus 9 over minus 4. So when I sub in f equals 13, I get G equals minus 12. That gives me a center of 12 minus 13. So remember, the center is minus G minus F. So the signs need to change. So when F is equal to minus 11, I sub that in, I get G equals 6. So again, the center is minus G minus F, which gives me minus 6, 11. So now I go to make my equations. The equation that's easiest to use is this one here, because we know the radius and we know the two, we know the h and the k, which we've called g and f. But here, if you go to use the other one, you're going to miss your c. So this is probably the easiest way to approach it. So I have x minus 12 to be squared plus y plus 13 squared equals 10 squared. Expanding that, I get x squared minus 24x plus 144. The second bracket, when I expand it, I get y squared plus 26y plus 169, and that all equals 100. Tidying that up, I get x squared plus y squared minus 24 plus 26y, and then 144 plus 169, take away that 100, I get 213 equals 0. Now, they didn't specify what form, so if you wanted to leave it in those brackets equal to 100, that would be absolutely perfect as well. So that's only my first equation of K2. My second one is going to use the second center. So subbing that in, I get x plus 6 squared plus y minus 11 squared equals 10 squared. I get x plus 6 squared as x squared plus 12x plus 36. Y minus 11 squared is y squared minus 22y plus 121, and that all equals 100. Tidying that up, I get x squared plus y squared plus 12x minus 22y plus 57 equals 0. So there are my two possible equations for K2. Question 2 is a coordinate geometry of the line question, and it is worth 30 marks. So the points A, B, and C are shown in the diagram below. Find the equation of the line through the midpoint of AB, which is perpendicular to AB. So let's start with our points A and B. So I'm going to label these x1, y1, x2, y2. Let's start with the slope of AB. So the slope is y2 minus y1, what's your signs, all over x2 minus x1, and that simplifies to 2. To then work out the perpendicular slope, we find the opposite reciprocal, which basically means we change the sign and flip the fraction. So my perpendicular slope is minus 1 over 2. I then get the midpoint of AB, which is minus 2 plus 4 over 2, and minus 3 plus 9 over 2, which simplifies to 1, 3. So then I work out my equation. My equation is y2 minus y1 equals m times x minus x1. Now for this equation, I'm using this as my m, and this is my x1, y1. So that's my y minus 3 is equal to minus a half times x minus 1. And then bring the 2 across to multiply it. I get 2y minus 6 equals minus x plus 1. And then simplifying that equation, I get x plus 2y equals 7. And that will be accepted in any form because they didn't specify what form they wanted it. So at 2y equals minus x plus 7, that's absolutely perfect. You could have x plus 2y minus 7 equals 0. They're all options for presenting that answer. So part B asks us to use our answer from part A to find the coordinates of the circumcenter of the triangle ABC. So part A was a big hint on how to get the circumcenter. So the circumcenter is when we perpendicularly bisect each of the sides, and then those lines where they meet, that will give me the circumcenter. The circumcenter is the point that draws the circumcircle, and it's quite a bad one, but gives you an idea. It's the circle that goes around the triangle and goes through all of its vertices, all of its points. So when we see questions like this, they usually are quite helpful in the first part to give us a hint of how to move forward. So I'm going to use AC. The part A gave us or got us to use a B. So you could also use BC here and get the exact, well, not the exact same answer for the equation. You'll get a different equation, but you will get the same final answer. I'm going to use, like I said, AC. So I'm going to do x1, y1, x2, y2. The first thing I'm going to do is get the slope of AC. And when I do that, I get 3 minus 3 minus 4 minus 2, which gives me 6 over minus 2, which gives me minus 3. I want the perpendicular slope, so that's the opposite reciprocal. So I flip it and change the signs. So the negative 3 becomes a positive 1/3. So then I get the midpoint of AC, which works out as minus 3, 0. And then I work out the equation. Just as before, my equation is based off this m and this x1 and this y1. So that's my equation. So if you can picture what we're doing here, we're basically getting, if we got the midpoint, say the midpoint is there, which it is, it will go like this through the midpoint so that this will be perpendicular. So that's the line we're looking for, and we will have already found it here, and we'll have drawn that in, and then we're trying to basically find where these lines meet. And it could be outside the triangle, and that's absolutely fine. So the equation is y minus y1 is equal to m times x minus x1. Watch your signs. And simplifying that, I end up with x minus 3y equals minus 3. Now, the way I'm formatting my equations, I'm formatting them because I know I'm going to do simultaneous equations as my last step. So I have the x and then the y and then the number. So again, any format there is absolutely fine. What I'm going to do to make this easier to use this in simultaneous equations, I'm actually going to change all the signs. So it'll be minus x plus 3y equals 3. And the reason for that is my previous answer from A had a positive x. So I want those x's to eliminate. So this was my answer from part A. This was then my answer from part B that I made negative. I'm going to put one over the other and I simply add them. I want to add them so that one of the letters, one of those variables disappears, so eliminates, the elimination method. So x minus x disappears and I'm simply left with y's and numbers which I can solve. So my 5y equals 10, so y equals 2. I take either equation. I'm going to take equation A and I'm going to sub my y back in. So I have x plus 2 times 2 equals 7. So x plus 4 equals 7. So x equals 3. So the coordinates of my circumcenter is 3, 2. So question 3 is a trigonometry question and it was worth 30 marks. So let sine A equals 1 over root 10, where A is between 0 and pi over 4. So that is bigger than 0, but smaller than pi over 4, which is 45 degrees. Find sine 2A and cos 2A in the form P over Q. Now, it seems like a big ask given us one piece of information looking for sine 2A, cos 2A. Where you need to go is you need to go to the identities pages, where we're talking page 14 and page 15 mainly in your log tables. But before we do that, I want to remind you that anytime they give us sine, cos, or tan, we actually are going to be able, without any other information, to figure out the other ratios. So in this case, they've given me sine, so I can actually work out cos and tan. So I don't need tan, I need a cos because that's going to be in the formulas for sine 2a and cos 2a. So how I do that is I draw myself a little triangle. In the triangle, I label my angle, in this question A. I then label my sides. So there's my opposite, my adjacent, my hypotenuse. Sine is opposite over hypotenuse. So based off that 1 over root 10, opposite is 1, hypotenuse is root 10. I can now use Pythagoras to find my missing side. So c squared equals a squared plus b squared. Here is my c squared. It doesn't really matter. I'll call adjacent a squared and I'll call this, sorry, that should just be c, and I'll call this a and that b. And subbing in, I get root 10 squared is equal to a squared plus 1 squared. That gives me a squared equals 9, so a equals 3. Now that I know my adjacent is 3, I now can get my cos. So cos is adjacent over hypotenuse. So the cos of A is 3 over root 10. That idea here is so useful, and it's one really to remember, that anytime I have sine, I can work out cos and tan, and the same with the other ratios. There's no need to go back and do sine inverse here, because the problem is they want our answer in the form of P over Q. And once you try go back and get the angle itself, you're going to find that you'll end up with decimals. And that's really why they ask for this in fractions, so that they know you're not just going to the calculator and working out A and then working out sine 2a and cos 2a. That will be straightforward. They want us to work out a very accurate answer for it, so no decimals, so working in this way. So in my log tables on page 14, I have two formula, one over the other, one for cos 2a, which is cos squared a sine squared a, and the other which is sine 2a, which is equal to 2 sine a cos a. Now just to remind you, cos squared a and sine squared a, that's our notation to saying cos A all to be squared, sine A all to be squared. The reason that square gets put in there against the cos and the sine is to make sure we're clear that it's the whole thing squared and not just the angle squared, which it would look like if the squared was on the outside. So I'm going to work cos 2a first because it was the first one in my log tables. So I put in cos A, which is 3 over root 10, and I square it. Take away sine A squared, which was 1 over root 10 squared. That goes straight into my calculator, or you can do it in your head. It's 9, so square the top, square the bottom when you're squaring a fraction. So it's 9 over 10 minus 1 over 10, which is 8 over 10, and simplifies straight to 4 over 5 if you go straight to your calculator. Sine 2a then is 2 times sine A times cos A, which gives me 2 times 1 over root 10, 3 over root 10. 2 by 1 by 3 gives me 6. Root 10 by root 10 gives me 10. So this simplifies to 6 over 10, or if you go straight to your calculator, 3 over 5. So part 2 says, by expressing sine 3a in the form of sine 2a plus a, find an exact value for sine 3a and give your answer in the form a root b over c, where a, b, and c are all natural numbers. So we go to our log tables to find something that will be useful. Remembering from the previous part I know sine a, cos a, sine 2a, and cos 2a. And this is what I come up with. Sine of a plus b is equal to sine a cos b plus cos a sine b. I'm going to rewrite it for my question to make it a little bit easier to follow. So sine 2a plus a is equal to sine 2a cos a plus cos 2a sine a. I then sub in what I know. So instead of sine 2a, I'm putting in 3 over 5. Instead of cos a, I'm putting in 3 over root 10. Plus, instead of cos 2a, I'm putting in 4 over 5. And instead of sine a, I'm putting in 1 over root 10. That can go to your calculator straight away, or you can work it out. We get 9 over 5 root 10 plus 4 over 5 root 10, which gives me a total of 13 over 5 root 10. I now need to bring it into the form where we've been asked. So just go back to this question here, and this is the form they wanted. They wanted it rationalized. Now, actually, if you put it into your calculator, it would have rationalized it for you straight away. And we end up with 13 root 10 all over 50. So part B of this question asks us to express 2 cos squared x plus 3 sin x minus 3 equals 0 as a quadratic equation in sine of x, and hence find all values of x where x is between 0 and 2 pi, which is 0 and 360 degrees, but we are dealing with this question with our answers in radians. So first thing I'm going to do is I'm going to go to page 13, and I find this little formula here, which is cos squared a plus sine squared a equals 1. Rearranging that allows me to change the cos to a sine, and that's what I was asking when at the question it said a quadratic equation in sine x. So in sine x basically means all of it is a sine x and there is nothing else. So we don't want that cos in there. So I'm going to rearrange this to have cos squared x is equal to 1 minus sine squared x, and I'm going to sub that in. So instead of my cos squared x, I'm putting in 1 minus sine squared x. Expanding that, I get 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. And simplifying it further, I get minus sine squared x plus 3 sine x minus 1 equals 0. Now we have our quadratic. I don't like negative quadratic, so I'm going to multiply by minus 1 or change all those signs, which gives me 2 sine squared x minus 3 sine x plus 1 equals 0. Now it's a very straightforward quadratic, and it's, shortcut for factorization of guide number. So if you want to leave it like that, that's absolutely fine. But I think the majority of students would find it easier if we change the sine x to something simpler. So I'm going to use a substitution of y, since x is already being used in the question. So I'm going to let sine x equal y. So everywhere there's a sine x, I'm going to put in y. And then obviously the sine squared x is going to change to a y squared. So I end up with this little quadratic here, which is very easy to factorize. I end up with 2y minus 1, y minus 1, and then my answer is y equals a half and y equals 1. So basically I found my answer for sine, and now I need to go back and figure out, when I know sine, what is my actual answer. And don't forget, those angles will be in radians. So when y equals a half, that's sine equals a half. So because I want all the answers in a rotation, so between 0 and 360 or 0 and 2 pi, I'm going to use my unit circle. So here is my unit circle, and here is my CAST. My two quadrants that I'm working in are the first and the second, since sine is positive. That means I'm working with this angle here, and then this angle, although it is x as well, it's also my reference angle, and that reference angle sits here. The angle I actually want is this bigger one here. So to get that, I'm going to do 180 degrees minus my reference angle. Because I'm in radians, it's going to be pi minus a. So in quadrant 1, when sine of x equal to half, I'm going to go to page 13, use my log tables and figure out, well, what is the angle when sine is a half? And the angle is 30 degrees, or in radians, pi over 6. So in quadrant 2 then, I'm going to have to do a little bit of a calculation. It's going to be pi minus pi over 6. So x is equal to 5 pi over 6. And that gives me two answers. There's no need for any rotations. We only use rotations where there's a coefficient in front of the angle. So if it was like sine 2x. So that's all of my answers for now. I do have a second value for y though. So y equals 1. So sine x equals 1. Now this is a strange one, because technically, yes, it's positive, but the quadrant it's actually sitting on the axis in between the two quadrants. So there is actually only one answer for sine x equals 1. And in our log tables, that's pi over 2. There is no other answers, because if we were to look anywhere else, we won't get that one. So that's my three answers that I get for that quadratic equation.